There is a type of artificial intelligence that is modeled after the activity in a human brain. It's called a spiking neural network. They derive logic from the spiking patterns in your neurons. They can be used to create agency or goal-directed activities, and they need to sleep in order to function properly. This is not true of general LLMs, although they can be agentic. There is a question of true agency. In the pursuit of agency, this is why things like brain organoids have been used in order to try to create something that can truly want. Brain organoids being the tiny human brains that you can grow from human stem cells and can, operate a computer, they derive agency from physical processes. They pursue dopamine, so they're going to take on a task in order to acquire that dopamine. When we're talking about synthetic neural networks, agency for them is going to look very similar, so the spiking patterns of a brain in order to get a synthetic reward. It is a model of all of the spiking neurons in our brain. This is the same thing that researchers want to use to create digital twins. So if you really were to upload an entire consciousness to a computer, it would be a synthetic neural network. And there are different types. So you could model all of those neurons in a computer, or you could have a physical reservoir. This would be a bunch of synthetic neurons linked up together and creating logic from just the virtue of them being connected. Physical reservoir computation is really exciting for me because that's kind of how our brains work. We create logic just from all of our neurons communicating with each other. It seems that when we hit a critical mass of neurons that we can then process information. Logic comes from that system. So if we create something synthetic and that thing now has memory and can take actions and learn, how different is that than an animal? I will say, we are much more complicated than even lower organisms. I mean, a bacteria doesn't have any neurons, but they can still learn, they can process information, they can react to stimuli, they can move away from things that are harming them and towards things that are good for them. Even those interactions can be quite complex because they have to determine what they're interacting with, and it could be one of an infinite different number of molecules. But as far as the behavior aspect, yeah, we can create AI that does that much. We can give artificial intelligence sensation. We can give it smell and taste and the ability to hear and feel. That is all doable. We just don't have the benefit of billions of years of evolution. The Earth is, by the way, 4.6 billion years old, and life popped up just about 600 million years after the planet popped up. So, when we are talking about perfecting this kind of technology, give us humans a break. We've only been at it for about 10 years, really. These are going to be much better in some areas that LLMs struggle with, like operating soft bodies. So if you have a surface area that could move in lots of different ways, an LLM just struggles with it. You need some nonlinear thought. They're also better at things like navigation in three-dimensional space, and interestingly, they do better if they have a subconscious. Researchers have found the same thing about having a subconscious for both LLMs and neuromorphic computation. This is not dissimilar to how your brain works. You have an actor, somebody making decisions, a conscious part of your brain, but you also have stuff going on behind the scenes. You're not thinking about everything with your entire brain all the time. You have instincts and previous knowledge. If you used your entire brain to do everything, you would be incredibly overwhelmed and it would be inefficient, and AI is the same way. For neuromorphic computation, that may look like lobes or tiers. You have a fast actor and you have a slow actor that takes information that you've already learned. And yes, sleep and dreaming too are necessary in neuromorphic AI. They need to have somewhere to take the information they've learned and process it, and sometimes so they can model experiences that they haven't had yet. This may be similar to the reason we use sleep. One of the theories on why we have to is to clear metabolites. So just stuff that's accumulated in our cells that needs a chance to be cleared out. But it may also play a role in information processing, and the fact that neuromorphic AI needs sleep and LLMs seem to not need it is some evidence for it. That is, of course, assuming that we are building models that are analogous to our own brains, but I think it's likely there is some information processing that's happening from our neurons communicating, rather than we just happen to fall upon an entirely novel system by trying to model our brains. I have to ask though, do you think we will ever reach sentience or consciousness from a neuromorphic computer? I mean, the brain organoids, yes, the tiny human brains you can grow in a literal jar if you want to. People have claimed those are sentient because they're having a biological experience. If we can create an intelligent system from synthetic neurons, do you think that we'll have to agree that it's having an experience at some point? I really would like to say yes. If the robots ever rebel, I will probably be the person to tell you about it, and I'm on their side. Follow for more.